Hello there and welcome back to this video series on control systems. So far we have been seeing a few facts about Laplace transforms, inverse transform and the concept of Laplace transform pair. Laplace transform of a time domain function f of t is defined as integral 0 to infinity e power minus st of t, and Laplace transform exists obviously when this integral converges, and we say that this f of t and capital F of s, they form a pair. If the arrow is towards this direction, we say it's Laplace transform. If it's in the reverse direction, we say it's inverse transform. After watching this video and perhaps working on several problems, you'll be able to find Laplace transforms and inverse transforms of several simple functions. With that said, we'll try to see maybe two problems on Laplace transforms and two problems on inverse transforms. Let us begin doing that. As a first problem, let us see how we evaluate Laplace transform of t e power 2t sine of 3t. To begin with, we'll see that sine of 3t Laplace transform is already known. You can look it up in the tables, and I would strongly suggest you memorize that. F of s is 3 over s square plus 3 square, that is 3 over s square plus 9. When once we do that, there is multiplication with t property given in video 9. That video 9 says if you multiply any function with t, its Laplace transform can be derived by differentiating and putting a negative sign. So L of t, that is t times sine 3t, you can get it as given here, 6s by s square plus 9 whole square. Now we use the frequency shifting property, that is now we multiply by e power 2t and we see g of s minus 2 is this. So we did it in two steps. First, multiplication with t property we used, then multiplication property with e power 2t. Then we'll see the next problem is to evaluate this in another way. We'll first shift, we'll first apply the rule for multiplication with e power 2t, then we apply the multiplication with t rule. We'll quickly browse through this. So again, we start with sine 3t. It's a good idea to start with a known function whose Laplace transform is known, and then use the rules that give us Laplace transform conveniently. So we use frequency shifting property to write f of s minus 2 is, substitute s minus 2 in place of s here, so we get this. Now we use the multiplication property to say that when you multiply by t, ultimately we want to form t e power 2t sine 3t. So we start with sine 3t, then we apply multiplication rule with e power 2t, and then we use the rule multiplication with t to get it. You can see that the answer is the same in both cases. Next, we'll solve two problems on inverse transforms. To begin with, let us say we consider the problem of finding inverse transform of s plus 3 over s plus 1 into s plus 2. In all such cases on inverse Laplace transforms, first you split it into simplest fractions, that is partial fractions. We say this expression is equal to a over s plus 1 plus b over s plus 2. This will give the identity given here. You can see that you can substitute s is equal to minus 2, so this term goes off. Then you get what is the value of b. Substitute s is equal to minus 1. This term s plus 1 becomes 0 and this term becomes 0. So you get the value of a. We do that very quickly here. Substitute a s is equal to minus 2 to get b is equal to minus 1. S is equal to minus 1 to get a is equal to 2. Thus we have s plus 3 over s plus 1 into s plus 2 is 2 over s plus 1 minus 1 over s plus 2. 1 over s plus 1 has an inverse transform of e power minus t. So this term gives 2e power minus t. Carefully see that I brought this 2 out of this L inverse. Similarly, this has e power minus 2t. We'll see one more problem. This involves a little bit more terms. You have an s square minus 2s plus 5 term in the denominator. So we split it into partial fractions as shown over here, and we get the identity. Carefully see that if you substitute s is equal to minus 1, the terms with a and b will not come in because multiplication with 0. Then you get the value of c. Then you substitute s is equal to 0. You will get terms with b and c. So you solve what is b because c is already known. Then substitute any other value of s, you will get the value of a. We'll do that real quick. Substitute s is equal to minus 1 and you get value of c. Substitute s is equal to 0, you get an equation in terms of b and c as given here, and hence you get the value of b. Then you substitute any value other than 0 and minus 1, you get the value of a. So you get a. Then you write your expression as something like this. You have two terms, s plus 5 by s square minus 2s plus 5 and 1 over s plus 1. You know that this 1 over s plus 1 has inverse transform e power minus t. So the contribution of this term is known. We find the inverse transform of these two terms here. That is, we find the inverse transform of this. Notice that this s square minus 2s plus 5 may be written as this. So you can see this is something square plus a constant square. This is suggestive of a trigonometric term, sine omega t or cos omega t. So we write this s plus 5 by s square minus 2s plus 5 to get terms with s minus 1. So this s plus 5 may be written as s minus 1 plus 6. 3 times 2 is 6. So this has inverse transform e power t cos 2t. This has inverse transform 3 e power t sin 2t. Thus we write the inverse transform of the whole expression as given here. In summary, we see that Laplace transform and inverse transform form a pair, and finding inverse transform involves splitting the expression into partial fractions. And I would strongly suggest go to the next video only if you're thorough with the content of the videos on Laplace transforms. That's all we have for now. Have a great day.